Good morning, everyone. Welcome to Building a Secure MLOps Pipeline featuring PathAI. Before I introduce myself, can you hear me okay? Thank you. My name is Raghavarao Sodabattina. I am a Principal Solutions Architect at AWS. My area of specialization is cloud security, data analytics, AI and ML. I help customers in building MLOps using various AWS services. I'm joined with our customer, PathAI, who built their digital pathology AISight product on AWS by using MLOps. Harsha from PathAI, he will introduce himself when he comes to his part of the presentation. Okay, let me ask you one question. How many of you know about what is MLSecOps? I see like a couple of hands here. Thank you. Let us quickly look at the agenda for today's session. First, I will talk about what is MLOps, how it differs from DevOps. I will also talk about value in building MLSecOps. And then I will deep dive into how to build MLSecOps on AWS by using Amazon SageMaker and various AWS security and compliance services. Harsha from PathAI will talk about their MLSecOps journey for building their digital pathology AISight product on AWS. At the end, I will conclude with few key takeaways. What is MLOps? MLOps stands for Machine Learning Operations. MLOps is a core function of machine learning engineering. It focused on streamlining the process of taking a machine learning model into production and then maintaining it and monitoring them. Again, MLOps is not just only the technology. It has to be a collaboration between people, process, technology. We will talk about how people, process, technology will come into play when you are building a MLOps pipeline. MLOps compared to DevOps. There are few features common across MLOps and DevOps. You can see here code versioning, artifact versioning, CI/CD, continuous monitoring. All these features are common across MLOps and DevOps. But you need to deal with few new features like model build, model deployment workflows, model retraining, model lineage. We will talk about all these additional features when I introduce a typical MLOps pipeline. What is MLSecOps? MLSecOps means introducing security very early in the ML lifecycle. MLOps compared to FMOps. Depending upon where you are with the leveraging generative AI foundation models, you will fall under three different types of personas under process and people. For example, if you are just leveraging foundation model as it is, you will come under consumer. But if you are bringing your data with the foundation model to get a domain-centric insights, then you will come under fine-tuning. It could be a fine-tuning. And if you are building your own model, then you will come under providers kind of a persona. Once you identify what design pattern you are going to use for your GenAI app, then you are going to select a model, and then you are going to customize to bring the specific context. And then you are going to evaluate whether that model, foundation model, is suitable for your use case or not. And then you will go ahead with the model deployment. And then application layers and MLOps process remains the same. Why MLSecOps is very important? Promoting a collaboration between the security teams, data scientists, and ML engineers. That way, you can align with your security best practices and security requirements. As I said earlier, MLOps means introducing security early in the life cycle. It can address vulnerabilities It also can help in maintaining the confidentiality of your models and the data. With MLSecOps, you can create a consistent, reliable, auditable path to production. But it is very difficult to build MLSecOps effectively. First, you need to understand what are the common security challenges associated with MLOps, and then you need to have a framework to address those security challenges. The objective of today's session is to understand what is the MLSecOps framework and what are the common security challenges across the MLOps pipeline and how you can address them. This is the typical MLOps pipeline. You see, it starts with the data preparation, where you are going to create a data for your model training. And then once you identify a data for your model, then you will get into model build, where you write a code for model development. And then once you develop a model, you are going to evaluate multiple models. Based on the model evaluation criteria, based on the metrics, then you get into the model selection phase. Once you define what is the best model for our use case, then you get into the deployment. Once model is deployed, you need to keep on monitoring because you need to maintain the model consistency and recency. Across this MLOps pipeline, you need to make sure that you put like a IAM, Identity Access Management Control, based on the user roles and personas. I'm going to talk about a couple of security challenges here, but the way we are going to cover this session is we'll take each phase one at a time, and then we'll look at what are the security challenges out there for each phase and how you can address by using different AWS services. For example, under data preparation phase, important thing is data poisoning. You need to understand how you can protect your data against the data poisoning. And also, you wanted to encrypt your data by using your own customer managed key. Also, you don't want to use like a sensitive data into your model training data. And when you are model building, in order to avoid model inversion attacks, you need to make sure that you develop models in your own private network. So we'll take one phase at a time, and then we will deep dive into a few of the security challenges. Building MLSecOps on AWS. AWS approach to build MLSecOps, people over process over technology. Let's start with the people. You need to understand what are the personas you need to collaborate and to build ML models end to end. The people personas could be across the organization, which includes security organization, which includes ML engineers, data scientists, data engineers, product managers. Again, processes. You need to identify the process and workflows involved to build ML model right from data preparation to deployment and monitoring and retraining based on the model performance and recency. And again, in order to enable both the people and process, you need to have a suitable technology. This technology is going to enable both people and process so that you can get the desired output from your ML model. Let's talk about MLSecOps people. If you look at here, data engineer involved in the data preparation phase. They create multiple data sets for ML model. And data scientists, they involve during the data preparation and model build. And DevOps engineer and MLOps engineer, they involve in the model evaluation, model selection, deployment, and model monitoring. And security engineer very closely works with the data engineer and the data scientist. During model selection process, model approver will come into play, and they are going to choose the correct model based on the business use case. Security analysts involve across the pipeline, right from the data preparation to model monitoring. MLSecOps process. As we talked about data preparation, during the data preparation, you are going to write a code for data preparation. And then you are going to build a model. During model build, you are going to write a code, training code, which includes you have to segregate your data, test data, validation data, and training data. And then during model evaluation, you are going to evaluate model based on various metrics. Based on the model metrics and model metadata, you are going to choose the correct model for your production implementation. That's where you are going to deploy the model. In order to deploy the model, you are going to write inference code. Once model is deployed, you have to keep on monitoring the model, make sure that model is giving the expected results and the recency. If model is not giving expected result, you need to look at retraining the model. And again, this is not one-time process. It is kind of an iterative process altogether. MLSecOps technology. Amazon SageMaker comes with MLOps ready features. If you look at network and application protection, you can create Amazon SageMaker within your own VPC. That way you can develop the ML model within your own private network. And Amazon SageMaker comes with IAM. You can create a identity and access management roles based on the user persona. Data protection. When it comes to data protection, you can encrypt data with your own customer managed keys by using KMS. Also, we have like various services for threat detection and instant response. Like we have Amazon Guard Duty, Amazon Inspector, Amazon Detective, and Amazon Security Lake. All these four together, you can put detective and protective controls. Again, Amazon SageMaker comes with a lot of compliance, HIPAA, PCI, SOC 1, SOC 2, FedRAMP, etc. Now, let us talk about Amazon SageMaker MLSecOps ready features. During data preparation, SageMaker comes with SageMaker Data Wrangler, where you can create a SageMaker processing job in order to make data ready for your model. And then it also comes with Amazon SageMaker Feature Store, where you can store some of the features. Model build, that's where you can use Amazon SageMaker Experiment to build different type of models. And then you can use SageMaker processing job. That way your model is ready. Once model is ready, then you have to choose the correct model for your deployment. That is where SageMaker model registry come into play. During deployment, it's very important. You deploy the model. That's where SageMaker comes with SageMaker Inference. With the SageMaker Inference, you can deploy the model across multiple regions or a single region based on your requirement. During monitoring, we have a feature called SageMaker Model Monitor. That's where you are going to continuously monitor the model, and then you are going to see the bias, and then you are going to see the metrics. Based on that, you are going to make a decision whether you need to retrain the model or you can keep the same model which is running in the production. Let's talk about the CI/CD practices here. During data preparation, you are going to create a data processing code here where you take the data and then you do the data engineering so that the data is ready for ML training. Again, model build, again, you are going to write a training code in order to train your model based on the algorithm which you choose. And then model deploy model, where you are going to write a model artifact code. Once model is deployed, you are going to keep on watching for the metrics. This is where you are going to look at the metrics. As I said, you are going to look at the recency and the performance of the model, and then you make a decision whether this model need to be retrained or you can continue to use. You can take a picture of this slide. Amazon SageMaker integrated with many AWS security and compliance services. As I said, we will take each pace one at a time, and then we are going to look at few common security challenges, and then we are going to talk about how we can use these services in order to address those security challenges. Let us start with data preparation. During data preparation, the common security challenge you could come across is data poisoning. Data is a foundation for your machine learning. You got to make sure that you protect your data against data poisoning kind of a scenarios. And then model inversion. Somebody can pollute your training data so that model will not perform the way it should be. And then how to encrypt your training data at encryption at rest. Also, when you're training the model, you wanted to make sure that you radiate the sensitive data, or sometimes you replace sensitive data with a few other filters. First one is encrypt your data. You can use AWS KMS, and it supports automatic and manual key rotation. Also, it comes with PIPs 140 level 2, level 3. And you can use Amazon KMS, AWS KMS, by using your own customer keys. The second one is Amazon S3 object log. With Amazon S3 object log, you can basically add another layer of protection. That way, you can detect the object changes and object deletions. Also, you can use S3 versioning. That way, you can preserve, retrieve, and restore every version of object stored in your bucket. You can also use Amazon backup so that you can store your model data in another region. Data exploitation controls. You can define a strict firewall rules by using AWS network firewall as well as Amazon VPC. You can also leverage Amazon private link. That way, you can you can build a private connectivity from Amazon VPC to Amazon SageMaker. That way, you are not doing any model development over public internet. Sensitive data protection controls. You have multiple options here depending upon your use case. First one is Amazon Macy. Amazon Macy uses machine learning to automate sensitive data discovery at scale. And you can scan Amazon S3 bucket with your model data, and then you can basically radiate PI, PHI related data. Also, SageMaker comes with Data Wrangler. Amazon SageMaker Data Wrangler, along with Amazon Comprehend, you can use these two together to radiate your training data as well. If you are using generative AI, Amazon Bedrock comes with the guardrails. With guardrails, you can set up some filters. You can also radiate PI kind of related data. In a general scenario, what many customers are doing, they remove sensitive data before using the training data for model training, or they will replace the sensitive data with something else, anonymous kind of a thing. Now let us talk about the model topic. As I said, right, in order to avoid model inversion, you want to develop your model within your own private network. Also, you wanted to have a segregated user bases. That way, you can develop ML models securely. Sometimes, you might need to bring third-party software libraries as a part of your model development. That's where you wanted to make sure that those third-party open source software libraries are no vulnerabilities in it. We talked about building a model development with your own private network. In this architecture, you can see that when a user is accessing the Studio, Amazon SageMaker Studio notebook, service injects an ENI into the VPC subnet for accessing your data or VPC endpoint without traversing to the internet. And here, if you look at right, you can also use VPC endpoints. That way, you can restrict the traffic within your own VPC. You don't need to worry about somebody is accessing your model development activity from internet. Protect third-party software with Amazon Inspector. Amazon Inspector is an automated software vulnerability service. It can continuously scan like AWS Lambda ECR. If you look at here, AWS Lambda, the standard version of Amazon inspectors can scan the software, and also you can enable code scanning. It can go and do the custom code spanning so that you can find out the vulnerabilities then and there. When it comes to Amazon ECR, many use cases, you will store a lot of ML libraries in Amazon ECR. Amazon ECR itself comes with a basic scanning. It can do the OS scanning, but you can enable enhanced scanning for OS and programming language vulnerabilities. Important thing is you want to understand what are the open source and third-party services you are using across your ML pipeline. That's where software bill of materials will come into play. It helps to find out open source and third-party components, and, so that you can see the complete supply chain. And then you can export the data into Amazon S3 or any third-party export tool, and then you can visualize by using Amazon Athena and Amazon QuickSight. Model selection. Model selection is a very important phase because you will be training and you will be doing like a multiple models in order to achieve your desired outcome. That is where you could come across some challenges like maintaining a model metadata, model versions, and model approvals. This is where Amazon SageMaker model registry will come into play. You can manage model versions. You can also associate metadata with a model. Also, you can also maintain the model approval status. And also, you can track the model performance by using the Amazon SageMaker model registry. You can also roll back some models back and forth. Amazon SageMaker model registry will make it easy for you. That way, you can do the model evaluation and choose the right model for your model deployment. Deployment phase. Deployment phase, very important security challenges is like a model poisoning. Sometimes, you also need to bring some software libraries. It could be a public or private libraries. And also, whatever the code you are developing for our model deployment, you wanted to make sure that you protect them. Let us talk about a few of the ways how you can control these security challenges. We always recommend apply least privilege to your training data, models, and applications by using AWS Identity and Access Analyzer. You can also use AWS Verified Access for fine-grained access controls, and also it validated application request before granting access in real time against predefined requirement. Let's say you define a requirement at the organization level, this is my security requirements, and in real time it is going to look at it whether whatever the access you are requesting, it is as per the security guidelines or not. With Amazon verified permissions, you can also build a secure application faster by managing authorization centrally. You don't need to do the basically isolated authorization. Instead, use the Amazon verified permission. That way you can manage the authorization centrally. Rate limiting is another way you can protect your models by limiting the number of requests that can reach to your ML model in a given period of time. So here, our model with an Amazon API gateway and a Lambda function on the top right, you are going to do the rate limit calls, and then you are going to add some noise to see how it is behaving. Based on that, you can see whether your model is being protected or not. If you see some noise, something obvious, then you can look at it replacing that model and putting some more security controls based on your investigations. So other way is, as I said, you're going to bring some software libraries. This is where you can use Amazon SageMaker lifecycle script. That way you can bring only the library what you want. In this example, we are just bringing Conda Python 3 library alone. Also, somebody, let's assume that your credentials are compromised. You wanted to protect your model. For that, what you can do, you can set up a service control policy at the organization level where you can create this SageMaker delete model and delete endpoint. That way, even your identity credentials are compromised, your model will not be destroyed. It will be there as it is. Now, last one is monitoring. Once you train the model, you did the evaluation, and you selected the model, and you did the deployment. Now, the important thing is you got to monitor the model end-to-end in a real time, and also you got to put some preventive and detective controls. That way, you can achieve the business outcomes, what you're looking from your model. Let's talk about how you can do that. SageMaker comes with a SageMaker Model Monitor. With the SageMaker Model Monitor, it can continuously monitor the quality of your model in real time. Amazon SageMaker model can even alert based on your model metrics. And you can track it right from the beginning, model data preparation to model deployment, and then model metrics. Amazon SageMaker Clarify, it integrates with Model Monitor. Amazon SageMaker Clarify provides purpose-built tools to gain greater insights into your ML models and data based on the metrics, right? The metric could be like looking at how the accuracy is and is there any bias, right? That way you can look at the model quality and then you can retrain the model and then do the, again, model performance and then make the decisions. So you got to put some preventive and detective controls. We have few services here. First one is Amazon Guard Duty. Amazon Guard Duty is a threat detection service that can continuously monitor your AWS work accounts and the workloads for malicious activity, and it provides you a lot of insight. Amazon Security Hub is a security posture management kind of a checks. It continuously monitor, it aggregate the security findings so that you can take the actions in real time. Amazon Detective, once you get a security events, Amazon Detective can be used to identify the root cause for those security events. Amazon Security Lake, you can create a security analytics kind of a data lake. That way you can derive the persona-centric insight. Amazon Security Lake integrates with many other services. For example, it can integrate with Security Hub, it can integrate with the CloudTrail. Once data is aggregated within the Amazon Security Lake, you can use any other AWS analytics services for deriving insights. Now, we covered about the security challenges across all these spaces. Now, you got to put identity and access management control across the pipeline. First, you need to make sure that you should be able to provide identity to your user by using your corporate directory. And also, you wanted to limit the access based on the user role or a job function. Amazon SageMaker comes with Amazon SageMaker domains. With Amazon SageMaker domain, you can isolate the resources and you can create the separate domains with the single AWS account. Also, Amazon SageMaker comes with the role manager so that you don't need to manually creating some of the roles. For example, it comes with roles like ML admin role, data scientist role, ML ops role. And IAM Identity Center, by using IAM Identity Center, you can provide access to your corporate users by using SAML federation. That identity center, identity provider could be Archer, Auth0, Ping Identity. And this is how you can provide fine-grained access controls with Amazon SageMaker. Here you can see we are restricting in the first example just to the single SageMaker Studio alone. In the second one, we are restricting the Amazon SageMaker Studio just for few IP addresses. At the end, here you are trying to do the service control policy. That way you are protecting whole pipeline. This is the simple architecture. We always recommend to have multiple accounts: development account, staging account, and production account. When model is ready, you use AWS code pipeline to promote the model to staging account and the production account. And when you are doing the model, you are going to retrain the many models. That is where Amazon SageMaker pipelines will come into play. And then you maintain the SageMaker model registry. That is where you are going to maintain the model versions. And then you are going to retrain against the baseline. The baseline model can be in a SageMaker bucket. From there, you are going to look at how the model is performing by using the SageMaker model monitor. Based on the model monitor and model metrics, you can use the Amazon Event Bridge. That way, you can basically retrain the model automatically instead of doing the manual process. This is the typical reference architecture. And let's look at quickly how it is different for FMOps lifecycle. Here, FMOps lifecycle in this architecture, you see you are going to choose the model, what model you are going to do it, because you are going to do the model evaluation in this space. And then based on the model evaluation, once you select the model, here the model could be LLM, foundation model, and then you'll fall into the same model version where you are going to look at the model registry so that you can maintain this model. And then once model registry is done, then you are going to monitor the model by using SageMaker model monitoring. Once model is monitored, then you are going to use that foundation model in order to integrate with your business application. With this, I will hand over to Harsha from PathAI. He's going to talk about how they leveraged MLSecOps concept, which I discussed, and how they're able to achieve their business objectives.
Hey everyone, give me a thumbs up if you can hear me well. Great. Thanks, Raghav, for the intro. Hey everyone, I'm Harsha. I'm leading the machine learning team at PathAI. Today, I would like to show you how we use AWS and third-party tools in building MLOps pipeline in scalable and secure way. So first of all, let me introduce you what is pathology. Pathology is the study of microscopic inspection of tissue. Generally, pathology is considered as gold standard for diagnosing the disease such as cancer and other diseases. Today, there are hundreds and thousands of pathologists across the globe who is taking patient samples of tissue and looking at these patient samples and diagnosing the disease. And each of these samples are microscopic in nature, and they have millions of cells, of cancer cells and normal cells. And pathologists have to do this job of reviewing all these cells and ending up with a diagnosis for patient to get different types of treatments. So because there are so many cells here, this is highly subjective, and it's time consuming because they need to review these thousands of cells and try to classify them into different types of cells and grade of cancer cells and so forth. So that makes their day-to-day job very burdensome. So here you can see there are multiple use cases for AI to be able to assist pathologists in generating insights from these pathology images so that they can help assist patients in getting the right treatment and right diagnosis. As well as one can generate a lot of insights from these images that can be shared with the research scientists who are in the drug development process. So there are many use cases for using AI in pathology, from translational research to clinical trials to diagnostics. So to solve this problem, PathAI was founded in 2016 to develop AI products and solutions to support many biopharma and lab customers. I'm lucky and grateful to join PathAI mission very early on as fourth employee in 2017 and continue to contribute to that mission so far. And today, I'm proud to say we're a global leader in providing AI and digital pathology solutions to top biopharma customers and lab customers within the US as well as outside of the US. So developing these end-to-end AI products is very complex. As I was mentioning to you, each of these images that you take from patient has millions of cells. So we need models to identify where there is tissue, where there is background, and within the tissue, where there is normal region, where there is cancer region, and different types of grades of cancer regions. And within the cancer region, you would like to learn about where are the cancer cells, where are the immune cells, and how are they interacting with each other in trying to attack the cancer. And pathologists who is reviewing these images would like to aggregate all this information across many of the cells and ending up with diagnosis. That's where you want to build these models that can aggregate this information and try to make a decision at patient level. So to solve this problem, it requires building multiple large-scale AI models to tackle each individual task and put them together to generate these features that can help with insights as well as help pathologists to assist the decision-making process. So because of that, these models are complex and create compute-heavy workloads. So let me share how we set up this process to develop these AI models in pathology. So at PathAI, we follow very standard model development process that most of you are already familiar with. However, there are some key differences that I would like to highlight to you all today. So coming to the dataset creation, as I was mentioning, each of these images are massive. These are gigapixel images. This can vary up to 100K by 100K pixels, making data to be a large-scale data problem. And each of these images comes with WSI labels and complex clinical metadata that you need to put together to be able to create data sets that model developers can use to train the models. So coming to the model training, we have to develop various types of models using open source and state-of-art methods to be the best in class to be able to help pathologists. So to ensure these models are most accurate, we rely on various types of training processes as well as architectures to develop these models. And then coming to model evaluation, we know that biology is a continuum. That means there is a lot of subjectivity in classifying different types of cells and cancer and so forth. So there, interpreting tissue is subjective, so we would have to rely on multiple pathologists' opinions. So we collect data from multiple expert pathologists to create gold standard so that we can create a consensus that you can use to evaluate the models in terms of the quality and the performance. And we also use pathologists to review our models when we develop so that they can QC it and give us both qualitative evaluation as well as quantitative evaluation using the consensus data. And once we have these models that we have built and got approvals from our pathologists saying the quality is good, we would like to deploy these models into the real world. So for that, we have developed our own AISight platform where you can deploy these models that can be accessed by pathologists across the globe. So here, we upload our models and make them available for pathologists, and pathologists can upload their patient tissue samples and run different types of models, and then review these model outputs, and then say these are good, these are bad, and here is where model has been failing, and share that feedback on our platform as well. So that feedback can be fed back to the model developers who has built those models and take that feedback back and try to iterate and improve the models further to be able to improve the performance and accuracy of those models in the real world. So given the above explained process, we have three key areas in which we need to set up best MLSecOps practices to achieve our business outcomes. One, we need to build scalable and secure data pipelines. So you all know how careful and critical the healthcare data is. So for us, data provenance and data protection to create standardized and secure data sets is key part of the dataset pipelines. And two, ability to build large-scale foundation models and then adapt these foundation models to various downstream tasks requires building scalable and secure MLSecOps pipelines for model development. And once these models are developed, you would have to deploy and continues to monitor these models in the real world. For that, you need to make sure your models are efficient both in inference and turnaround time, as well as you have tools in a secure way that you can collect this feedback back and share that feedback to your model developers so that they can iterate on it. So MLSecOps best practices are key in all these three categories of work to build and deploy best-in-class AI models in both scalable and secure way. So in connecting PathAI business objectives with AI model development, we have to consider security practices across the life cycle. So in this slide, I would like to share some of the key security consideration and best practices we use with AWS and other third-party tools, laying out the same way that Raghav has explained how to set up this pipeline. And going to the first topic around data preparation, given the importance of data, data poisoning is a key security consideration we have considered very early in our journey. So we use, to able to protect the data and track the data, we use different tools on AWS like AWS KMS, Amazon S3 Object Log, and Macy to able to track the data and provide that data to model developers. While developing these models, to be the best in industry, we have to rely on adopting open source state-of-art methods, and we have to rely on some of the third-party software packages and code libraries and so on. So there you might have a security consideration around like any type of compromises that this code libraries and third-party packages might bring. So we conduct routine vulnerability checks of our code libraries, containers, base images using SNCC to reduce compromises very early on in our ML lifecycle. And once you have trained these models, once you have evaluated your models on your pre-collected ground truth data, you go into the model selection. Here you have ML developers training so many models with so many hyperparameters and evaluating on this ground truth data that you have created. And we want, in the model selection, we would like to share our models with our expert pathologists so that they can review it and approve these are of extremely high quality so that we can go forward to the deployment. So here, we always try to track these models where they're being stored and try to generate metrics for all of these models and create model manifest which has metadata so that you can make sure your models are consistent as well as the recent models are being ready to be deployed. And here we use tools like Amazon S3 and CloudWatch in able to track some of these objects of the models that we are selecting. And going to the deployment, model poisoning is one of the key considerations, as Raghav pointed out in this ML lifecycle. So here we have set up CI/CD pipelines to be able to move our research models from research account to the production account where pathologists can use. Here you can use different tools to support this process. And once you have deployed these models on your platform, you have to continue to monitor these models so that you can get that feedback from pathologists who is reviewing these models and share that feedback back to the model developers. So for us, end-to-end, ML model auditability is a key consideration. So we tag all the images and Git builds and create like model manifests and track them over this entire life cycle so that when we receive any feedback from our pathologists, we can share that feedback back to the developers. So here we use different tools like AWS CloudTrail, Amazon GuardDuty, and AWS Security Hub for security practices. And throughout this life cycle, providing right privilege access to the right set of stakeholders is key consideration. So to basically follow the data integrity and safety. So here we use AWS IAM and AWS IAM Identity Center to provide right access controls to right set of users at various stages of this life cycle of developing models. Here is our super high-level architecture connecting all the various components in the ML lifecycle. However, I'm not going to bore you by going detail into every object here. At high level, I would like to share that we have separated the entire pipeline into 3 big accounts. What you see on the left side is a research account. What you see on the top right corner is staging account. And the bottom right is production account. So we have ML engineers getting all the data and ability to train the models with so many different techniques and parameters and evaluate them and getting feedback from expert pathologists in-house in deciding which models to deploy. And once a model is approved, we use Docker images and package the entire model and the sequence of models and then use CI/CD pipelines in shipping these research models to the staging account. Once we move this into staging account, we want to test the integration between these models as well as our distribution platform called AISight to be able to make sure that these are well integrated and the features from these models are able to share it on the platform as well as these meet the additional tests such as turnaround time requirements and cost requirements and following all the specs of the product. So once models and the product passes through this criteria and tests, then we upgrade it to the production account through CI/CD pipelines and launch them on the AISight platform where pathologists can access the models and use them in their day-to-day for research use. So building these pipelines and following best practices must also support the business scale. So here, I'm showing some of our metrics on the current scale of MLSecOps, which is growing rapidly with increased customer adoption of our AI products. So far, we have processed 1.5 million plus whole site images. As I was mentioning, each image has hundreds of thousands of pixels, making a lot of this data to be thousands of terabytes to be processed. And so far, using our pipelines, we have collected 24 million plus annotations to be able to train our models of high quality. And in developing these models, we have run over 250,000 model training experiments so that we can pick the best models for right use cases. And in those experiments, we have run 17 million plus whole site inference runs, and we have 200 plus machine learning models in production and 30 plus end-to-end AI products in research use today. And to be able to build these many models and products, one needs to have scalable as well as secure pipelines. And for us, ability to set up that process is very key part of our journey. And here I would like to show some of the business outcomes we have achieved by intentionally following MLSecOps over the years. So here few examples include developing an idea from a concept to a prototype. We are able to take that down from months to weeks by increasing the developer velocity as well as providing all the tools in developing prototypes. And once you have these prototypes and the models, ability to standardize the delivery of ML product from research to production also needs to be very efficient and secure. So here we use CI/CD workflows for all the 100% of the models to reduce any types of errors and issues that you might face when you are moving from research to the production. To improve reliability and security of ML products in production, we established common practices for packaging our models and as well as testing those models in the staging account. And by doing that, we are able to reduce time to move these models and test these models from weeks to days, which increase us way to deploy these models into production and test them out and get feedback from our users. And to address different types of vulnerabilities, we have used these practices very early on in the ML lifecycle, with which we are able to achieve zero critical or high-risk exploits in our ML products. So I would like to conclude that MLSecOps plays a critical role in developing AI products in scalable and secure way. Finally, I would like to thank AWS team for providing this opportunity to share our story with you all. And thank you for listening. And I would like to hand it over to Raghav for key takeaways.
Thank you, Harsha. So Harsha talked about the power of MLSecOps, introducing security early in the life cycle. So key takeaways, when you are building a ML model, think through something. Number one is, can you solve the business problem by writing a code or using a role engine? If you can do that, then you don't need ML model. That's the important thing. But if you cannot predict or you cannot solve the problem, then ML model will come into play. That's where we always recommend introducing security early in the life cycle. I want to talk about MLOps maturity model. As I said, it is an iterative. Start with very small and try to take one single business use case, try to apply MLSecOps across the pipeline, right from the data preparation, model build, model evaluation, and model metrics, and deployment, and monitoring, and see how you can measure your success. The way PathAI explained, they got some KPIs and metrics to measure whether model is performing in order to achieve their business outcome. Once you see how to measure your success based on the KPIs and metrics, then you can scale it across different units within your organization. So to put everything together, data is the foundation for your ML model. And it is a foundation for generative AI applications as well. I mean, there are a lot of foundation model, but without bringing data to the context, you are not going to achieve your business outcomes. So let us start with first. As I said, encrypt your data with AWS KMS with your own customer managed keys. That way, nobody can decrypt your keys, or nobody can look at your keys and all. AWS will not have access to your KMS customer managed key. You control your keys. And if you are dealing with any sensitive data, you can use either Amazon Macy, or you can also use guardrails for Amazon Bedrock for generative AI applications. Once data is encrypted, you wanted to make sure that your data is accessible only to the respective people. So that's where you have to give like a IAM resource-based policies or identity-based permissions. We talked about an example where Amazon SageMaker comes with the role manager, where you can create a persona-centric roles without worrying about how to create. So that is where we always recommend that provide least privilege access to your data. Once you are done with providing access control, you need to monitor your data. Who is going to access your data? That way you can use AWS config. That way you can see is anybody is monitoring your ACM certificate or KMS keys by using AWS CloudTrail and CloudWatch. That's where you are going to do the data protection assurance. Again, during ML model development, you might need to deal with many application constants. That's where we always recommend it to use either AWS Secret Manager or AWS System Manager Parameter Store. If you are looking for automated key rotation, go for AWS Secret Manager. If not, then leverage AWS System Manager Parameter Store. Again, implement least privilege access to either your Bedrock models or ML models. Also, do all the model development within your own private network and restricted user access at API level. Once your model is ready, your business application is going to consume that model. Make sure that you provide access to those models who need it. And also, very important thing is implement data in transit by using AWS ACM. At the end of the day, once model is ready, your business applications are going to consume that model. That's where edge protection, application protection is also important. We recommend use AWS WAF, Amazon CloudFront, Amazon Shield. That way, you can protect your application as well. It all end-to-end protection is important. This is the depends in depth data protection on AWS. I'll wait for a minute. You can take the picture of this. Okay, if you want to learn more, I wanted to share some of the thing. I'll also wait for a minute to take the picture. On the left side, we talked about how to build a secure machine learning platform on AWS. It talks about MLSecOps concept. And also, when you are doing the model development, it talks about how you can establish a private connectivity with Amazon SageMaker by using your private VPC. Also, when you are building generative AI application, it talks about security scoping matrix, and also overall how you can bring in defense in depth security controls by using OWASP top 10 LLMs. And the second part of thing, it talks about Amazon SageMaker MLOps. If you look at here, you have some important artifacts here. It talks about how you can put the MLOps foundation. Also, it comes with a few GitHub examples. Whatever the security concept, I talked about it. It comes with the VPC sample SageMaker notebook. That is where the other one. And rest of the thing is all about how you can build security into generative AI application. At the end, you see AWS well-architected machine learning lens. I would always recommend it to refer to them. It talks about when you are building a model, it talks about all AWS well-architected pillars. Thank you so much for your time.